Hi, hi, my name is Nguyen.
Hi, my name is Tsung-Yang.
My name is Chun-Wei.
My name is Khoa.
And we're here to like walk you through our project in which we combine all the knowledge that we learned in the course involve like the transition between industrial 3.0 to industrial 3 4.0, which is like we have the PLC and the basic PLC with the more like Lego demonstration for the conveyor, photosensor, um, and what we try to achieve is try to collect the data that generate like the status that from the conveyor on the speed, the status of conveyor, and how many part that the process is done, and all the communication will be done through a cloud and then monitor by using an application on the phone, and also try to utilize the Mobus and then control the system remotely.
Yeah. So I will talk about the hardware implementation. So we will use a Modbus to control the PLC, and then PLC will control the conveyor, and then PLC will publish the message to the cloud, and then we will use our cell phones to subscribe from a broker. So then we can get a message like the motor status, motor speed, and part count. And then he will introduce the software implementation.
Okay, so basically this is our code in a CCW. So the first line is about connecting to the broker, the MQTT, the mosquito public broker. And the second part is to like enable the conveyor belt. So when the first sensor detect the object, and it will enable the conveyor belt, and when the second sensor detect the object again, and it will disable the conveyor belt. So the next few line is about the Modbus. So when the Modbus change the variable MB int, and it will change the speed. And if the Modbus change the variable like the address 3, and it will change, it's like the emergency stop, so it will stop the motor right away. And the last one is when the Modbus variable got changed, and it will reset the counter that we use to count how many items have been passed through the conveyor belt. And the next one is how we control the speed of a conveyor belt. So when the conveyor belt is enabled, but it's a default speed, and we won't change, and we won't stop. But when we change the speed of a conveyor belt to slow speed, and we will stop the conveyor belt for 2 seconds and run it for another 1 second. So the total cycle is 3 seconds. Okay, so and next one is there's a timer, and we keep running, and when the timer is greater than the 2, and it will run the motor and also publish the enable message, which is motor on. But when the motor, when the time on, the time variable is less than 2, it means that we won't run the motor, so the motor will stop. So the next 2 lines to publish the message, the enable message. And next 2 run is to publish the disable message, which is motor off. So it includes the 2 condition, which is disable when the sensor detects when the sensor 2 detect the object, and also the emergency stop. And next 2 run is to count is to count how many items have been passed through the conveyor belt. So we said there's a counter here, and we said the maximum number is 100, and because the CCW has a default variable that the number will begin in 0. So we add the process here, and we change it from an integer to the string, which can be published through the MQTT, the publish function. So the next one is to publish the count, and the next two is to publish the default speed, and next two is to publish the slow speed. So let's get into the demonstration part.
Yep.
So the demonstration is, first we have to connect our PLC to the broker. And then
we will put our items.
we will open our cell phone, the MQT tool application, and this one will subscribe the topic of motor speed, and this one will subscribe the topic of part count, and this one will subscribe to the
motor status.
Yeah. So
we will put the items on the conveyor belt.
Yeah.
It will run in the default speed, and then when the sensor 2 detected the items, and the conveyor belt will stop, so I can subscribe on and off.
You forgot this. Try it.
Okay, I will try again. Yeah, so I got the part count 2.
Yeah, part count 2.
And we are in the default speed.
Yeah.
So when we use a Modbus to change the speed to the slow speed, we change the address from 1 to 2 to a slow speed. Okay, so we'll try again.
Address to
Address 2 to 2.
No.
Address 1 to 2. So
1
yeah, address 1
to 2.
Yep. Okay, so yeah,
Yep.
so we are in the slow speed mode.
So it will start for 2 seconds and run for 1 second. And we can see that in the motor speed, there's a slow speed right here. So we successfully change the speed to the slow speed and also publish the speed result. Yep.
Yeah.
So
And we will change the address 1 to 1 back to the default speed. Yep. And then we change the speed back to the default speed successfully, and then we will reset the counter. So we change the address to 1. Yep. So when we run the conveyor belt again, and we can see that we can try it again. You can change it again. Yeah, change the number to 1 again. To 1. Yep. Yep. We can try again.
Mine crashed out.
And we can try the emergency stop. So when the conveyor belt is running, and we can change the address 3 to 1 to stop the conveyor. Yeah, and the conveyor will stop, and it means that our emergency button is working, and that's our demonstration.
So what will you do for future work and for this project?
As you can see here, with this simple setup with one PLC and one conveyor belt, we were able to kind of show that with some adoption of some new technology, we can transform a traditional automated system to a in a industry 3.0 setup to a industry 4.0. Obviously, there's still a lot of space for improvements, such as connect multiple PLC and conveyor belt together. So that's the first thing. Second thing, we might add some more sensor on the top of the existing system, such as camera. Computer vision is a big thing nowadays. To kind of detect the part, do the segmentation, or somehow communicate with a robotic arm to detect the object and then send a coordinate to the robotic arm to go to that object location and grab it and do some kind of pick and place or color sorting or stuff. And then the last thing would be we could try out some other wireless communication. So now here we using MQTT, as a basis, but in the future we might try to integrate ROS, which is implemented on the top of OpenDDS, with the pub sub architecture. Try to integrate ROS and kind of replace MQTT with ROS. Or even better, we can just integrate direct OpenDDS directly with the system instead of using ROS. And yeah, that's pretty much it. Thank you.